Hi, good afternoon everyone. I am Dr. Javan Susanka. I'm a veterinary officer in the Ministry of Agriculture, Land and Fisheries, and I am here today to talk to you about anthelmintic resistance. So, the reason I chose this topic is mainly because anthelmintic resistance is something we see all the time out on the field. A lot of farmers want to know why 20 years ago they would have used a dewormer and it works, and now 20 years later the dewormers don't work as well. So that is the purpose of this lecture. I'm going to go into detail about why dewormers don't work as well as they used to. So first, what is an anthelmintic? It is derived from the words anti and helminth, the Greek word for worm. So it basically means a dewormer, and it is used to treat animals with infections with parasitic worms. It should be noted that infestation with parasitic worms is referred to as endoparasitism. There are different types of anthelmintics. There are three main classes used in livestock, and they are the benzimidazoles, the imidazothiazoles, and well, this is what's happening here. By using dewormers, we are creating an environment where the worms need to find a way to survive, and they survive by passing on genes for resistance to the dewormers that we use. Whenever they mate and reproduce, they will pass it on to the next generation. So what causes anthelmintic resistance? In any given population of worms, there will be those that carry the genes for resistance to a certain drug and those that do not. When an animal is dewormed, those worms that carry the genes for resistance have a higher chance of survival and are therefore able to pass on these genes to the next generation. It should be noted that resistance to one drug in a class of dewormers confers resistance to all drugs in that class. So for example, we had this picture here with the different type of dewormers. If a worm is resistant to fenbendazole, the worm will also have some level of resistance to albendazole. It should also be noted that different brand names may have the same active ingredient, meaning that a lot of farmers will be thinking that they're changing their dewormer every 3 to 4 months by buying a different brand name. But what you really need to look at is the ingredient on the brand name to decipher whether it's the same active ingredient you're using or not. So this diagram goes into detail about how anthelmintic resistance develops. The yellow worms that you see here represent non-resistant worms, and the red worms represent resistant worms. Every time you deworm an animal, the yellow worms in that animal, the non-resistant worms, are going to die off. You're going to have some level of them dying off, and it's going to increase the rate at which red worms meet with each other and mate and reproduce and multiply. So you're going to have an increase in the amount of red worms, right? And this happens every single time you deworm. So how is anthelmintic resistance diagnosed? There are many ways to diagnose it, but one of the main and most common ways used is the fecal egg count reduction test. So what your vet would do is he would take a fecal sample from an animal and look at it under a microscope. And all these oval shapes you see here are eggs from worms, right? Then the vet would treat your animal, and what he should see, he would take another fecal sample after he treats, and what he should see is a complete reduction in the amount of eggs, right? And if this does not occur, and after treatment it still looks like this first picture on the left, then you have a resistance problem on your farm. It means the dewormer that you used to deworm the animal is not working. So how do we prevent anthelmintic resistance? There are many ways, and I'm going to go into each one in detail. The first one is do not mass treat your livestock. What I mean by this is a lot of farmers would want, let's say you have 20 animals, they are going to deworm all 20 animals. One of the reasons you don't want to do this is because you're going to kill off most of the non-resistant worms that you have present in these animals, and you're going to end up with all your animals only carrying resistant worms, and passing on, these worms will be passing on their resistance to the next generation and just building up the number of resistant worms on your farm. The second thing is, do not underdose. When you underdose an animal, you're exposing these worms to a level of wormer that they're not going to die from, and they may develop resistance from that, right? So it's always important to follow the guidelines on your label and use a weight tape or a scale to accurately get the weight of the animal before you come up with your dose. The third way is pasture rotation. Now, in reality, a lot of farmers in Trinidad do not have sufficient pasture to rotate pasture properly if they have many animals. But if you have, let's say, 2 or 3 animals, you could parcel out whatever land you have so that every month your animals only graze a certain amount of pasture. Ideally, pasture needs to be rested for up to 3 months to get rid of the eggs present on the pasture. Also, it is important to know that you should not allow your animals to graze when it's early in the morning, because the larvae from the worms will climb up the blades of grass, and as the day gets hotter, they go back down. The fourth point here is to increase herd immunity through proper nutrition. Now, increasing the health of your animals is one of the best ways to control worms. You don't want to have to deworm. Deworming should be a last resort, right? You want healthy animals that could actually fight off worm infections, and one of the ways to do this is to increase the immunity through proper nutrition. The fifth point is selecting for livestock resistant to infection. And what I mean by this is, if you have an animal that you find you have to deworm often, let's say 3 to 4 times a year, because they're showing signs of endoparasitism, which is infection with worms, right? Those are animals that you don't want to keep on your farm because they are not resistant to parasite infection. So you want to cull those animals, and you only want to breed animals that you find that you don't have to deworm often, and they will pass on their resistance to worm infection onto the next generation. One of the things to note is oral drenchers should be used as opposed to injectable wormers, and this is because worms develop resistance to injectable dewormers at a much faster rate than they do with oral dewormers. The use of raised slatted flooring and the cut and carry system for livestock management is one of the best ways to control worms. This is because animals pick up worms because they pass out eggs in their feces. The raised slatted flooring is having the animal in a raised pen with spaces in the flooring for the feces to come out, so you limit the interaction of the animal with the feces. And the cut and carry system means that you're going to cut grass for the animal and bring to the pen. And this grass shouldn't have any fecal contamination, and therefore wouldn't have any worms on it. Right? The last and final point is on all caps, because it is the most important. You only want to treat livestock that require treatment. And what I mean by that is, you only treat livestock that's showing signs of endoparasitism. And by doing this, you increase the refugia, which I know is a technical term, and I'm going to go into detail about what refugia is. So, the term refugium is classically defined as an area in which a population of organisms can survive through a period of unfavorable conditions. In the context of drug resistance in animal parasites, a refugium refers to untreated hosts or environments that allow the maintenance of drug-sensitive parasites in the face of drug exposure. And what that means is, on your farm, what you want are worms that are sensitive to the drug that you're using, right? So this diagram goes into further detail about refugia. So let's say you have 2 animals, right? The red worm represents resistant worms, The yellow worms represent non-resistant worms, right? Note that this one worm doesn't mean it's just one worm in the animal. There will be multiple resistant worms in this animal and multiple non-resistant worms, right? So let's say you deworm 2 animals, so you're mass treating your livestock here, right? These are all the animals you have, you deworm both of them, right? This space on the outside here represents your pasture. So you have one resistant worm here and a few non-resistant worms. So your level on the pasture is 8% resistant worms and 92% non-resistant worms. You deworm both animals, so you're going to kill off all these yellow worms in the second animal here. So you're going to end up with this. This animal just has resistant worms in it, and this one has none, right? Now, because this animal only has resistant worms in it, those resistant worms are going to meet with each other inside this animal and mate and reproduce and release eggs, right? And all those eggs are going to be resistant worms. So you actually just increased the number of resistant worms on your farm, because the eggs would have been released through the feces and they would hatch, and your level of resistance on your pasture went up to 27%. And then now these 2 animals are going to graze, and then they're going to pick up. So an animal that never had a resistant worm in it before then picks up resistant worms because the level of resistance on your farm has increased, right? So let's say, for example, we only wormed out this animal alone, right? Because this animal had signs of endoparasitism and this animal was looking healthy. Even though he has more worms, he was looking healthy, right? What you're going to end up with is this red worm will still be surrounded by a good bit of yellow worms, non-resistant worms. So the chances of this red worm meeting another red worm to mate and reproduce to make resistant worms would be less. So this is what you want in an ideal situation. You want less chance of this red worm meeting other red worms to reproduce and make resistant worms. So what are the signs of endoparasitism? I'll just give you all a refresher. First one is bottle jaw, which is a swelling underneath the jaw of the animal. The second one is ascites, which is the swollen abdomen. Both these symptoms occur because of fluid buildup in these areas. This happens because of a lack of protein in the blood caused by endoparasitism. The third one is diarrhea. The fourth one is lethargy and weakness, what a lot of farmers would call laziness is seen in the animals. The animal is walking and struggling to walk or falling sometimes when it walks. The fifth one is inappetence, which is a decreased appetite. And the sixth one, and the most important one, is pale mucous membranes, which can be evaluated using the FAMACHA system, right? So we're going to go in detail about the FAMACHA system. The FAMACHA system was developed by these individuals here, and it is used to evaluate the mucous membranes of ruminants to determine the extent of the barber pole worm, which is the Haemonchus contortus. The mucous membrane that you're evaluating is the eyelid, which can be seen here in this picture. Now there are different types of worms, and they include flatworms such as flukes, tapeworms, and roundworms, right? The barber pole worm in particular is the most economically significant parasite affecting small ruminant production. And this is because the barber pole worm has the ability to lacerate the abomasum, which is the true stomach of the ruminant, and cause blood loss and subsequent anemia. Anemia meaning that there's a decreased circulating red blood cell in the animal, right? So this anemia is what causes the lethargy and weakness that you see in severe cases, and eventually the anemia can lead to death of the animal. So the FAMACHA system is what we use to control the barber pole worm infestation. It has found a lot of success in Africa. So this is a FAMACHA scoring card. If an animal has, so you pull down the eyelid of the animal, and if an animal has red or pink mucous membranes, which is this membrane here, that animal you do not worm out, right, is because this animal is still healthy, right? Even though the animal may have tapeworms or something that panics a lot of farmers is they might see clumps of tapeworms coming out in the feces. Now, tapeworms do not cause as much damage as the barber pole worm. So if an animal has tapeworms but their mucous membranes are red, I would suggest you don't worm out that animal, right? So if the mucous membranes are red or pink, you do not worm out that animal. If it's pale pink, the only reason you should worm out that animal is if it has other signs of endoparasitism, such as the bottle jaw, swollen abdomen, diarrhea, etc. If it's pale or white, that animal definitely needs deworming, right? And the FAMACHA scoring chart is one of the main ways you use to select your healthy livestock for breeding. So what I suggest to my farmers is that every month you check your mucous membranes of your animals, right? And if you have animals that are always red and pink, you do not deworm them. These animals are resistant to parasite infection, mainly the barber pole worm, and these are the animals you want to continue breeding in your farm, right? If you find an animal has pale or white membranes consecutively, these are the animals that you don't want to breed and you want to get rid of from your farm. So in conclusion, the end goal should not be to eliminate all worms. This is unrealistic and is quite frankly impossible to do. As long as your animals are eating grass or out on pasture, they will have worms, right? There's no way to get rid of all the worms, right? What you want on your farm are animals that are resistant to worm infection and could have worms and still produce for you, whether it be meat or milk purposes, right? Your use of dewormers should be your last resort. Only if an animal is showing signs of endoparasitism, these animals should be dewormed, right? The question should not be how often do you deworm your animals, because a lot of farmers want to know how often should I deworm, every 3 to 4 months, and that shouldn't be the question you're asking. You should ask, when should I deworm my animals? And the answer to that is when your animal only shows signs of endoparasitism, do you deworm your animals. And as I said before, when you have animals that are found to be resistant to helminth infection, those are the animals that should be bred so that they could pass on their resistance to the next generation. Now the final point is, resistance is something that we will continue to see develop for all our lives, right? But our actions or our inaction will affect the speed at which it develops. So the less we use dewormers in the future, 10 years from now, when we choose to use a dewormer, hopefully it will work because you followed all the directions I gave you here. So these are some resources for you. There are some good videos here going into further detail about anthelmintic resistance and also the use of the FAMACHA scoring card. And these are my references. And now we have time for any questions you all may have. No questions? Give people 2 minutes. Alright, I saw Dr. Lana Gyan asked a question in the chat about the different classes that we talked about earlier. So I'll just go back to that slide. So yes, we did just mention the different classes of anthelmintics, and she was asking about self-treatment, right? Yes, you should not do self-treatment without consulting your vet, because what that ends up being is one of the main reasons we got to this point where resistance has developed so severely is because of farmers' ability to access the rumors over the counter, right? They don't need to even talk to a vet or get a prescription from a vet. So they would go to the agro shop, buy the rumors, and then they would go and mass treat all of their livestock. And this would have happened like 20 years ago or more, right? And it's still happening today. And we went over what happens when you mass treat your livestock. You're going to kill out all your non-resistant worms on the farm, and you're going to end up with just resistant worms. And then 5 years from then, or 10 years from then, your dewormer doesn't work anymore. Any other questions? Cool. Alright folks, well, that's it for me. Nobody seems to have any questions for me, so yes, that's the end. Thank you very much for listening, and hope to see you all next time.